Question 10 reads, in the diagram below, circle center 0 passes through F, S, H, and G. So we have F, S, H, and G. They tell us that DF and DS are tangent to the circle at F and S respectively. DF is parallel to SG, and FOH intersects SG at R. They want us to prove that the triangle DSF is similar to the triangle OGH. So let's take a look at the triangles that they are talking about. They are talking about DFS and triangle OHG. Well, we'll start with the triangle DFS. We know that if we have lines that are drawn from, or tangents that are drawn from the same point, then it would tell us that DF is equals to DS, and that would also mean that F1 is equals to S3. Right? So tangents drawn from a common point would tell us that DF is equal to DS, and therefore we can say that F1 is equals to S3. This is an isosceles triangle. Then we would look at the relationship between F1 and S1. We are told that DF is parallel to SG, and therefore F1 should be equal to S2. And the reason behind this, we would say alternative angles. Then we look at S2 and H1. If we look at our quad, let's see if we can draw out the quad to clearly see it. S to F, F to H, H to J, and J to S. We can see we form a quadrilateral, and we will see that S1, S2 and H1 are going to be equal to each other, and the reason would be angles in the same segment. Now, because the line OG is and the line OH are equal to each other, the reason being is that they're both radiuses. So OH is equals to OG. That would mean then that H1 is equals to G1 plus G2. And we can see that that's also equals to F1. So we will say that triangle DSF is similar to triangle OHQ and that is because all of their angles would be the same. Angle is equals to angle and angle. You can show the last angle. In this case, that will be your O1 here, and the last one will be D. This is because D is equals to O1, and the reason is the sum of angles in a triangle. But by just proving the two, we know this to be true.